Alright, in this video we will be dividing fractions. What we're going to use is just one rule. We're going to use keep change flip to turn division into multiplication. Keep change is for subtraction. Keep change flip is for division. Because when you dividing by a fraction, it's the same thing as multiplying by a reciprocal. That's the idea. So we're just going to use keep change flip to turn a division problem into a multiplication problem. Now I set these three examples up on purpose. 2/3 divided by 2/3. Now we already know a number divided by itself should be 1. Well, let's see if that's the case if we do keep change flip. So what we're gonna do is keep the first number, change the division to multiplication, and flip the other fraction to 3/2. Now you can already see the 3's would cancel and the 2's would cancel, but let's just multiply them. Top numerator times numerator, denominator over denominator. 6/6, which is 1. Let's do the cancellation rule for the next one. But first we have to do keep change flip. So 4/3 times 9/16. 3 goes into 3 once, 3 goes into 9 3 times, 4 goes into 4 once, and 4 goes into 16 4 times. So 1 times 3 is 3, 4 times 1 is 4, 3/4, it's reduced, and that's it. So all we're really doing is switching this division problem and switching it to multiplication problem, which we already learned how to do. Now, just like before for number 3, these are mixed numbers. We want to convert them into improper fractions. So we multiply the whole number times the denominator and add the numerator. 2 times 3 is 6. 6 plus 1 is 7. Keep the denominator. Keep the sign. We're not doing keep change flip yet. 3 times 5 is 15. 15 plus 1 is 16. Keep the denominator. 5. Now we do keep change flip. 7/3 times 5/16. And if you look, we try to cancel top, bottom, nothing, top, bottom, nothing, diagonally, nothing, diagonally, nothing. They have nothing in common. So we just multiply. 7 times 5 is 35. And 3 times 16 is 48. And since I couldn't do any cancellations, this should be my final answer, 35/48. It cannot be simplified. Now, this is how you are pretty much doing division and multiplication. You're trying to simplify the answer by dividing out the GCF or by doing cancellation. Since we learned how to do cancellation, since we learned how to do the greatest common factor, we now know how to simplify fractions. But what if we try to make two denominators the same, like if we're trying to add or subtract, which I will be doing in my next video? Well, in order for you to add or subtract fractions, you're going to need the same denominator. So we're going to learn something called the least common multiple. Now, the least common multiple by definition is for 2 or more numbers, it is the smallest number that those 2 or more numbers can all divide. They all have to divide that number. So I wrote out an example. The LCM of 12 and 15. This is how you write LCM, by the way, in mathematics. So what you do is you write the multiples of 12 and the multiples of 15 out. 12, 24, 36, 48, 60, 15, 30, 45, 60. And you stop once you see a match. 60. So the LCM of 12 and 15 is 60. And just like we did in the other video where we used prime factorization, I want to do the same thing. So I wrote out 12 and 15. Again, take the smallest prime factor that you can think of, 2 times 6 and 2 times 3. So 12 is equal to 12 squared times 3 to the first. And do the same thing for 15. 3 times 5, and that's actually the prime factor for 15. That's it. 3 to the first times 5 to the first. Just a quick review from the last one. If we were to do GCF of 12 and 15, GCF pretty much takes out the smallest exponent. if you think about this, this is also 5 to the 0 because 5 to the 0 is 1, and this is 2 to the 0. So if I picked out 5 to the 0 and 2 to the 0, that would be just 1 times 1. Now I have to pick out the smallest 3, and that would be 3 to the first. And pretty much 1 times 3 times 1 is just 3. The GCF is 3. But if you were to use this for LCM, it's actually the opposite. The least common multiple takes the greatest that they all have. So the greatest for 2 and 0 is 2, so it would be 2 squared. The greatest for 3 to the first and 3 to the first is still 3 to the first. And the greatest for 5 to the first and 5 to the 0 is 5 to the first. So 4 times 3 is 12, 12 times 5 is 60. The least common multiple is 60. And these are shortcuts to figure out the GCF and LCM, which I recommend in case you have like really big numbers. For example, let's just get a new piece of paper. I want to show a little bit of this. Suppose we want to find the least common multiple and GCF of 7, 21, and 28. Well, 7's easy, it's a prime, so it's just 7 to the first. What about 21? You know what? Let's not use 7. Let's use 21, 28, and 49. That'll be more interesting. And as you can see, these numbers are really huge. So 21 is 3 to the first times 7 to the first in order. These are the primes. 28 is 3 times 4. 7 times 4, but 4 is just 2 squared. So 2 squared times 7 to the first. And 49 is just 7 squared. So let's fill this in. I'm missing, there's no 2's here, there's no 3's here, there's no 2's or 3's here. Just so we can see, and let's use our rule for GCF and LCM. For GCF, we take the smallest power. So for 2, we have 2 to the 0. For 3, we have 3 to the 0. For 7, they all have 7s, but the smallest number is 1, so 7 to the first. So the GCF of all 3 numbers is 7. 7 divides all 3 of these numbers, and there's no number greater that can divide all 3 numbers. And if we take the LCM, we take the greatest. So for 3, it would be, we start with 2 actually. So for 2, it would be 2 squared, right? Because I have a 2 squared right here. For 3, I see 3 to the first would be the greatest. And for 7 is 7 squared. Now if you take this, 4 times 3 is 12, and 12 times 49 is actually 588. That is the least common multiple. And just to prove it, this is going to take a while. But if I were to write out the multiples of 21, this would take me a long time. Right, it's already taking me a while. 210, I'm not even halfway. Let's just skip. If I double 210, it should also be a multiple. So 420, 441, 462. I shouldn't have skipped because how am I going to show that there was nothing else? 504. Hold on a second. 420, 441, 462, 483, 504, 525, 5, 4, 6, 5, 6, 7, and 5, 8, 8. See, that would take a lot of work. And I would do the same thing for 28 and 49. And you can try it. You can keep writing out all the multiples of 21. And then you will see that the only one that all three have in common is 588. So let's see, 49, 98, 147, 196, 245, 294, 294 would have actually been here, but 21 and 49 have 294 in common, but 28 wouldn't have it. Anyway, as you can see, this is getting kind of repetitive, but it would be so much harder to find the least common multiple of three numbers using the write it out method when you can just simply break them up into the prime factorization and do this. So if there's ever a time where you run into very large denominators that you're multiplying by, we'll use this method, and you'll see in the later video. So thank you for watching.